Okay, welcome to Lesson 8. This lesson is called Sequencing, Reflections, and Translations. So in Lesson 7, we saw what happens when a figure is translated, and we saw how we could undo the translation with the opposite vector. And in Lesson 8, we're going to look at reflections. And first thing that we can see right off the bat, if I want to take the reflection of this diagram here, I'm going to draw my line of reflection or trace it on my paper. I'm going to trace line point Q, point P, and point A. And if I reflect this about line L, then I can see that the image of P, this becomes P prime. And this right here is A prime. Oh, sorry. A prime would be over here. A prime. So that, they move to the opposite sides of the line of reflection. And if I want to undo this reflection, it's pretty clear that I can use the same line of reflection and just flip again. So a reflection is its own inverse or its own opposite translation. With a vector, remember if we translated by vector AB, some figure, that to undo that, we had to translate by the opposite. We had to translate by BA. So we had vector AB. The undo was to translate by vector BA, but a reflection is its own undo, basically. It will always be its own inverse. But in this lesson, we're going to look at something a little different. We're going to look at, this time we're going to combine reflections and translations, and we're going to find that the order matters. That we're going to find that if you do a translation and then a reflection and then try to undo it, that you will have something different. If you do it in a different order, you will get a different image. And so we're going to look at that and so what I'd like you to do is look at this exercise, exercises 1 through 3, and work on those on your own for just a minute. Okay, so we're going to talk through exercises 1 through 3 here. So they all three of those use this diagram. So hopefully you found the questions on the next page. If not, those are the exercises, so you can pause and look at them before you listen to me talk about them. Okay, so I'm going to read number 1, and it says figure A, which is this one right here, was translated along vector BA, which is right here, resulting in translation of figure A right here. So if you want to use your overhead to try that, then it would look like this. So I could trace out my vector, and A, trace my figure, translate along the vector, and show that that's the image right there. Okay, but what's our question? Let me get this back in here. Describe a sequence of translations that would map figure A back onto its original position. Okay, so like we just said, if I want to map it back onto its original position, then I'm going to need to translate along a different vector, and I'm going to use vector AB that way. So I want to translate the translation back, and it's going to look like this. So if I translate on vector AB, then it will take me back to figure A. So let's see how we would write that. you should have something. So we translated figure A along vector BA. So to get it back to its original position, the next thing in the sequence, so let's write the whole thing. So we translate figure A along vector BA, then translate the image of figure A along vector AB. And I can write vector AB like that. So we translated figure A along BA and then translated the image of figure A along AB. Okay, so let's look at the next one. Bring my picture back up here. So here we are. Figure A was reflected across line L, resulting in reflection of figure A right here. Describe a sequence of reflections that would map figure A back onto its original position. Okay, so this one's pretty simple, right? We're just going to reflect it back because, as we just talked about, a reflection is its own undo or its own inverse. So we reflect figure A across line L. Then reflect, and this is just getting us back to our starting point, reflect the reflection, then reflect the reflection across line L again. Okay, so we reflected it and then we reflected the reflection and we got back to where our original position. Okay, so here's a question. Can translation BA, and that's this vector over here, of figure A undo the transformation DC of figure A? Why or why not? Well, hopefully you can see that I've still got this drawn. So here's figure A. If I translate this along DC, it would take me over this direction. And then if I take this image along vector AB, it's going to move me down here. So that's not an undo for that. That's pretty intuitive. So hopefully you could see that the answer to that would be no. No. Can translation be a undo the transformation of translation DC? To undo the transformation, you would need to move it back to its original position. So if we move down this way along DC to get back, we're going to need CD, and this would not be that translation, the undo of that. So go ahead and you can write that out for exercise 3, and then we'll come back and do another example together. Okay, now we're going to kind of investigate if the order of translation or transformations matters. Okay, so we have a figure here. This is figure E, this ellipse, and we have a line of reflection, and we have a vector. So we're going to first do the reflection, then the translation. So here's I'm going to do the reflection now. So I'm going to trace this and trace my figure. You could try something similar. You can just watch this for right now. I'm going to find a point on my line so that I can, when I flip it, I'll know where I am. So there's my point. Okay, so when I reflect this image, there we go, match up my line. Here is the reflected figure E. So it's right in here. Pretty close. Okay, so let's call this reflection E. Right here. Okay, and now I'm going to take reflection E and I'm going to translate it along vector AB. My red's not very good right now. Okay, so I'm going to take this and then translate it along vector AB. And here is our translated ellipse right here. Okay, so this one here is reflection first. We'll call it reflection, then translation. Okay, so the question is, so here's our final image after the two transformations right there. So our question is if we translated first and then reflected, would we get the same result? So we're going to do it and find out. Okay, so I have another one of these that I've drawn somewhere. And we will do the same translation. Okay, let me find it. Okay, so this is reflection, then translation. Now we're going to do the same thing, except we're going to do the translation first, and then the reflection. And I know I've already told you we're going to get a different result, but let's go ahead and do it. My red is drying out, so I'm going to use green. So we're going to translate along vector AB, and we're going to translate this image. So it comes down like so. Let me trace it. So this will be our translation of E. So there's translation E right here. And so I did the same translation, but in a different order. So now I'm going to take the translation of E and reflect it across line L, right here. And you can already see it's ending up in a completely different place. There's I need a point on the line to make sure I get it in the same place. So there's my point. So I'm going to just flip it over, and my image ends up on a completely different place. So here's my image right there. So this one is translation, then reflection. Translation, then reflection of E. Okay, so let's compare the two. Let's get them both on here. I don't know if I can get them both on here, but that's where it ended up. It's on the upper side of the line. Here's let's kind of trace it in color so we can see where it ended up. That is translation, then reflection. Over here in our diagram is reflection, then translation. So the order matters when we do reflection, when we combine reflections and translations. Okay? All right, so what I would like you to do now is find exercise 4 and 5. It's this diagram right here. Use this diagram for exercise 4 and 5. It asks you to do a translation and a reflection, very similar to what I just modeled for you. So use your transparency. First translate figure S, then reflect and label it S prime. And then you're going to do it again. You're going to first reflect, then translate and label it S double prime. Okay, go ahead and pause the video and do exercises 4 and 5. All right, let's look at exercise 4 and 5. And I'll just work through it together. You can check your work. So it says there's a translation along vector AB and a reflection across line L. Okay, so I'm going to trace out my figure. I'll just do there's our black figure. It says in number 4, it says to first translate figure S. So this is S here. I'm going to translate it along the vector AB. And when I do that, it moves it on this side of the line of reflection. So I'm going to copy it. Whoops. Should end up somewhere right down here. And I know some of you are concerned about being messy, and you could just be as accurate as possible. And so there's my intermediate step. And now it said translate and then reflect. So I'm going to stay right here, trace out my line of reflection, and I'm going to trace this point right here since it's marked so that I get this flip in the right place. So now I'm flipping my overhead, lining everything up, and there's my reflected image right here. And there, and there, so I can draw it. Okay, and I'm told to label this one S prime. So there's S prime. Now we're going to do it in the opposite order. I'll start over here. And so I did the translation first, then the reflection. So this time I'm going to start again with figure S. This time I'm going to reflect across line L first. Mark this point. So flip across line L, and there's where the intermediate step is, but I'm not done yet because I still have to translate this image. Like that. Okay, so now I'm here, and I'm going to trace my vector now, vector AB. Right here, and there's my intermediate step. I'm going to go down right here, and it's almost off the page. So this ends up, this image ends up right down here. And this is S double prime for exercise 5. So we have completed exercises 4 and 5. These two were just the intermediate steps between translation and reflection. So S prime is translated first, then reflected. This is reflected first, then translated. So you can see beyond a shadow of a doubt now that order definitely matters. Okay, what I'd like you to do now before we move on to exercise 6 is to watch there's a video in your playlist that's about 1 minute and 41 seconds, I believe, called Composition of Rigid Motions, and it's done by someone who's much better at animation than I am. And it shows you a sequence of transformations, and it uses all three. It uses translation, reflection, and rotation, and it maps a figure onto another figure to show that they're congruent. So that's where we're going with this, to be able to prove these things in geometry. So go ahead and watch that video, and then we will talk about exercise 6 and 7. Okay, this example 6 here uses a lot of words to tell you to do something fairly simple. You get to decide what figure you want to draw and what translation vectors you want to draw. So you get to draw a figure. It could be something simple like a box or a triangle or whatever you want to do. But what you're going to do is to translate along the vectors in different orders. So you'll have 2 vectors. There's no reflection here. So let's read it and see if we can figure out what it's saying. Using your transparency, show that under a sequence of any 2 translations, and they're going to be called translation and translation O, just to distinguish them, along different vectors, that the sequence of the translation followed by translation O is equal to the sequence of the translation O followed by translation. So we're going to have 2 different vectors. These aren't the vectors that undo one another. These are different vectors. That those will be equal. So we're going to see that those are equal. You're going to do this twice, okay? So let's see. They're restating this. So that is draw a figure A and 2 different vectors. Show that the translation along the first vector followed by a translation along the second vector places the figure in the same location as when you perform the translations in the reverse order. It says here this fact will be proven in high school. So you can look forward to that. Label the transformed image A prime. Now you're going to do it again. So we're just going to double up. We're going to draw 2 new vectors, and you can use your same figure A, translate along them just as before. This time, label the transformed image A double prime, and then compare your work with a partner. Okay, so we're going to try this twice and make sure that we map to the same place each time. Okay, so if you didn't understand that, you can reread it and try to make sense of it, and then I'm going to demonstrate it for you here. So try it yourself and then come back and we'll try it together. You can also answer question 7 at the same time. Does the same relationship you noticed in exercise 6 hold true when you replace one of the translations with a reflection? Okay, so for this one, you'll be thinking back to exercise 4 and 5 that we just did. Okay, so go ahead and pause the video and work on that on your own, or with a partner, with your parent or somebody would be great. And you're supposed to compare your work with a partner, so that would be a good thing to do if you can get someone else in your house to do this. Otherwise, you can compare your work with mine, which I'm going to show you in just a minute. Okay, go ahead and pause the video and work on that. Okay, this is how I drew my diagram, and you might have drawn yours, well, I'm sure you drew yours differently. So I'm going to first translate along AB and then along CD, and I'll call that A prime. So let's trace my figure and trace my translation vector. Okay, and I'm going to translate A there. Now I'm going to do this in one motion here. I don't need to draw the intermediate step. So if I now I take vector CD here and I translate my figure on CD, I get this image over here. So this is going to be my A prime. All right, I'm going to connect the dots for this triangle. Okay, so this is A prime. All right, so I did AB first, then CD. This time I'm going to do CD first. So translating CD would do that. And then I'm going to do AB. And translate along vector AB. And you can see that A double prime, or no, this is just A prime, again, along those two vectors ended up in exactly the same location. Okay? All right, so if you're unconvinced or you want to be really sure, let's draw two new vectors. We're still going to use let's draw one right here. We've done A, B, C, D. We'll call this E, F. And how about one straight down like this? E, F, and we'll call this G, H. Okay, so I'm going to translate this same figure again. Let's do, so we're translating A. Now we're not going to match up with this A prime because we're using totally different vectors. But let's use FE and translate. We'll do FE first and then GH. Okay, so there's FE. Then let's do GH. I'll bring it down. And there's our image. We'll call this one A double prime because it's with our second set of vectors. Okay. So there's A double prime. And then we're going to do those in the reverse order. So let's start again with A. This time we'll do GH first. That takes us there. And then we're going to do FE. And that transformation will take us right over to the same location. Okay, did you see that? FE, we slide it down, matches it up. Exactly. Cool, isn't it? So you, if you answered number 7, you should have said, pause it if you haven't thought about it yet, but it says, does the same relationship you noticed in exercise 6 hold true when you replace one of the translations with a reflection? No. We already saw that in exercise 4 and 5 and in the example I did before that. It says, that is the following statement true? A translation followed by a reflection is equal to a reflection followed by the translation. No. And we can answer in a complete sentence. The translation, let's see, what do I want to say? Followed by a reflection would put, let's see, would put the image in a different location. In a different location on the plane or something like that. Okay, a different location than the reflection followed by the translation. Okay, So that's pretty interesting, really. So what it says is that you have to pay attention to the order that you're doing these sequences of transformations in. And if something you're trying to do doesn't work one way, you could maybe try to do it another way. So let's talk about what we kind of saw in this lesson. So make this a little bit bigger. So we saw that a reflection across a line followed by a reflection across the same line places all figures in the plane back onto their original position. So in other words, a reflection undoes itself. And then a reflection followed by a translation does not place a figure in the same location in the plane as a translation followed by a reflection. The order in which we perform a sequence of rigid motions matters. So the order matters. Okay, enjoy this problem set, have fun, and we'll be back with lesson 9 tomorrow.